that sits in a bony pocket in the base of the skull called the pituitary fossa. The pituitary fossa is also known as a sella turcica, which translates to Turkish saddle because it resembles a saddle with supports in the front and back used by the Turkish people. Despite its small size, the pituitary gland plays such an important role in controlling the body that it is often called the master gland. There are actually two main parts of the pituitary gland. The front portion, commonly referred to as the anterior pituitary, is also known as the adenohypophysis. The back portion, or posterior pituitary, is called the neurohypophysis. We can keep these two names straight by noting that the words anterior and adenohypophysis both start with the letter A. The pituitary gland is attached to the hypothalamus by the pituitary stalk, which contains nerves and a unique circulatory system which enables communication between the two. Let's take a closer look at the way the hypothalamus and the pituitary gland work together. A good way to visualize the relationship between the hypothalamus and the pituitary gland is like the president and his chief of staff. While the hypothalamus, or president, makes the decisions, the pituitary gland, or chief of staff, executes those decisions by sending out commands to the rest of the body. The hypothalamus monitors the body through the circulatory and nervous systems. When it detects that something is out of balance, it sends a message to the pituitary gland that a corrective action is needed. When the pituitary gland gets this message from the hypothalamus, it releases specific hormones into the bloodstream that can stimulate other endocrine glands, organs, or tissues depending on what action is needed. It's kind of like a game of telephone. Instead of the hypothalamus communicating directly with the body, it relies on the pituitary gland to send out the messages. The hypothalamus continues to monitor the state of the body, and if it detects that balance has been restored, it tells the pituitary gland to stop sending out stimulating messages, thereby stopping the corrective action. An example of this process is when we become dehydrated. The hypothalamus is able to detect the increased blood concentration caused by the loss of water. To correct the situation, it uses the posterior pituitary to release antidiuretic hormone, or ADH, into the circulatory system. When ADH reaches the kidneys, it causes more water to be reabsorbed into the bloodstream, diluting the blood. When the hypothalamus detects the return to a normal blood concentration, it stops the release of ADH from the pituitary gland, and the kidneys return to normal functioning. The hypothalamus communicates with the anterior portion of the pituitary gland by way of hormonal messages. These messages come in the form of hypothalamic releasing and hypothalamic inhibiting hormones, which tell the anterior pituitary to start or stop an action. Located in the pituitary stalk, a unique arrangement of capillaries and veins called the portal system allows the hypothalamic hormones to pass directly to the anterior pituitary without circulating through the body. The anterior pituitary contains glands that produce and store a number of different hormones that control many different functions throughout the body. When a hormone message comes down from the hypothalamus, the anterior pituitary releases its own hormones into the main circulatory system to control the needed action. These pituitary hormones can stimulate other endocrine glands, such as the thyroid, the adrenal cortex, and the gonads. The anterior pituitary also sends growth hormone to the bones and muscles, and prolactin to the mammary glands to stimulate milk production during pregnancy. The hypothalamus uses the posterior pituitary like a warehouse and distribution center. Antidiuretic hormone, or ADH, and oxytocin are both produced in the hypothalamus and sent through axons to be stored in the posterior pituitary. When the hypothalamus detects that either of these hormones are needed, they are released from the posterior pituitary into the circulatory system to do their jobs. As mentioned earlier, ADH works on the kidneys to increase the reabsorption of water into the bloodstream, but it also causes the constriction of blood vessels to increase blood pressure. Oxytocin is responsible for stimulating uterine contractions during childbirth and the release of milk during nursing. The posterior pituitary differs from the anterior in two distinct ways. First, it interacts with the hypothalamus through direct axon connections, not by hormonal messages. Secondly, it does not produce any of its own hormones, but rather stores and releases hormones produced in the hypothalamus. That means that this part of the pituitary gland contains no glands at all.